Welcome to the Explainer. All right, today we're diving into something that sounds like it was pulled straight from a sci-fi novel, a plan, a real business plan to build a gigantic AI superbrain on Mars. And yes, it comes with a $1 trillion price tag.
Now, before you dismiss this, get this. This isn't some wild internet rumor. Elon Musk himself has actually confirmed it. It's a real part of the long-term vision for his company, X.AI. So yeah, this is on the roadmap.
It sounds completely counterintuitive, right? I mean, why on earth would you build a supercomputer millions and millions of miles away? You've got this massive time delay for the data. Well, believe it or not, the logic is surprisingly solid. Let's break it down. To really get it, the story doesn't start on Mars. It actually starts right here, on our home planet, with a huge, and I mean huge, problem that's putting a ceiling on the future of artificial intelligence. You see, AI is getting smarter at this just incredible exponential rate, but it's about to hit a hard physical wall. The sheer amount of electricity and, just as importantly, cooling that these systems need is exploding. We're literally running out of planet to power and cool the next generation of AI. And to give you an idea of just how insane the cooling problem is, a single next-gen AI data center could need a constant flow of water that's a big fraction of the entire Mississippi River. That is just not sustainable on a planet where we're already worried about water. No way. So, if Earth is hitting its limits on land, power, and water, where do you go? Well, it turns out the answer might be our little red neighbor. And Mars isn't just, a backup plan. It's almost uniquely perfect for solving AI's biggest headaches. Think about it. Mars has about the same amount of dry land as Earth, but with no oceans in the way. It's naturally freezing cold, which is perfect for cooling computers. There are huge amounts of frozen water just under the surface for any extra cooling you might need. And the ground itself provides shielding from damaging space radiation. It ticks all the boxes.
And power? Oh, the power potential on Mars is just staggering. With that thin atmosphere, you can soak up so much more solar energy. We're talking enough to power an AI system 1,000,000 times bigger than anything we could ever hope to build here on Earth.
And what this all boils down to is efficiency. Here on Earth, a huge chunk of energy, sometimes 20%, just gets wasted on cooling, on fighting the heat. But on Mars, in that natural deep freeze, nearly every single watt of power goes directly into computation. It's about as close to perfect efficiency as you can possibly get. Okay, but let's get back to that big question, the elephant in the room, the lag. The speed of light is the speed of light, and it can take up to 20 minutes for a signal to get from Mars to Earth. How could an AI ever be useful with that kind of delay? Well, the answer, and this is the key, is knowing that AI systems do two very different jobs. There's training, which is the super heavy-duty, long process of actually building the AI model. That can take months. And then there's inference. That's you asking the finished model a question and getting an instant answer. Only one of those really cares about the time delay. See, the latency just doesn't matter for the hard part. The Mars data center would only do the training. You can think of Mars as the university where the AI goes to get its PhD. It's a long, intense process. But once it's done, the finished product, the trained model, is just sent back to Earth as a file. And for that, a 20-minute delay is completely irrelevant. And the end game here is to build something truly epic, something right out of classic sci-fi, a world mind. Imagine a single planetary scale intelligence. An AI so powerful it could dedicate itself to solving humanity's biggest, gnarliest problems, curing all diseases, figuring out fusion, you name it. Its potential would be beyond anything we can currently comprehend. The leap in intelligence is just hard to even wrap your head around. If we use IQ as a very rough metaphor, an AI that's a 200 IQ genius here on Earth could become something like an 800 IQ entity if it's trained on Mars. The value of that kind of breakthrough, it's basically incalculable. And that word, incalculable value, is the secret sauce. That's what turns this from just a cool science project into the economic engine that could actually fund humanity's entire future in space. So here's the business model. You build this planet-sized AI training center on Mars. That allows you to create an unparalleled superintelligence. The breakthroughs and technologies from that AI generate revenue so vast, we're talking thousands of trillions of dollars, that it can single-handedly pay for the whole shebang, a permanent self-sustaining city on Mars, and maybe even terraforming. When you're generating that kind of revenue, the unbelievable cost of launching, say,
1,000 starships to Mars to build a city. It becomes trivial. It's a rounding error on the balance sheet. The AI pays for everything. And don't think this is some dream for 100 years from now. The first steps are already in motion. The absolute critical first move is to prove an unmanned starship can actually land safely on Mars, and they're targeting 2026 for that. Once that's done, you can start sending fleets of robots to begin building the whole thing out before the first people even set foot on the planet. So it really leaves you with a fascinating thought, doesn't it? For decades, we've looked up at the stars and wondered how we'll ever afford to go there and stay there. And maybe, just maybe, the answer wasn't out there at all. Maybe it was right here, in the silicon chips we're creating. Perhaps the future of AI and the future of humanity in space aren't two separate journeys, but the very same path.